Hey everyone, in today's mini lesson, we are going to be looking at outputs from a graph. So, like last time, you're going to watch this video. You can pause, speed it up, or stop it whenever you need it, or come back to it if you need it as well. But after you finish this, you're going to go ahead and complete Delta Math 7. It is due by the end of the class period. If you need more time, you have until 11:59. It will lock at 11:59 and not be reopened. So, let's jump into it. We're looking for outputs. In our last video, we were checking out inputs. Outputs, we know, are our y values, and that looks a little bit different when we have our equation. So here's our graph, f of x, and for this problem, we want to know where f of x is equal to 5. So when y is 5, what is x? Whenever we have like the fancy notation f of x equals, that's our output notation. So if y is 5, we're kind of going to do the opposite of what we did in the last video. We're going to go start at the origin again, 0, 0. Since y is positive 5, we're going to shift up 5 units and go from left to right and see where are we touching our function f of x. We can see that we touch it right here. And we want to know what x is. So we look down at the x-axis and it's between -1 and +1. That means x is equal to 0, and we would get out 5. So another thing you'll see here on Delta Math, you would just type in x equals 0. But to bring everything full circle with what we've been learning, we have f of 0 equals 5. This means when x is 0, we get out an output of y equals 5. Here's our next problem. A different graph, also f of x. And for this, we want to know for all values of x, where f of x is equal to 0. Again, f of x equal to 0 means when the output is 0, aka when the y values are 0, what is x? So we'll start at the origin, 0, 0, and we're going to go to y is equal 0. Remember, you can kind of think of the y values going like this on the graph, and you'll see I can like shift it up. So if I was going up to y equals, if I was going to see like y equals 9, I would look up here. If I wanted to say y equals -3, I would be looking down here and see where it intersects my graph. However, for our example, we want to know when y is equal to 0, which is going to be right here. It's lying basically right on top of the x-axis, which can be a bit tricky, but we do see that it touches our graph right here at x is equal to -3. So in the box below, you would just type in x equals -3 and click submit. But again, just to bring it full circle, this means when we have -3 for x, we get out the output of y. So we were given the output and our goal was to find the input. Okay, here's another example. Here's our graph. This one is looking like a U. Here, this says to find all values of x for where f of x is equal to 4. Again, when y is 4, what is x going to be? When our output is 4, what is x going to be? Starting at the origin, 0, 0. Since y is positive 4, we're going to go up 4 units, 1, 2, 3, 4, right here, and go horizontally. And here, you'll notice on this example, that line at y equals 4 touches our graph twice, over here on the left and over here on the right. So if we look down at the x-axis, x is equal to -1 and also +1. So you can have one answer, you can have two answers, you can have multiple answers, or you can have none at all. So notice that it said find all values of x. Here there was 2. In the last example, there was just 1. The most important part, I think, is recognizing that we are looking for when the output is 4 and trying to find x. Here's our very last example that we have. Here's our graph. Kind of looks like the last one. We want to find the value of f of -2. All right, check it out. This guy did a switch up on you. Here, we have an input. We have that x is equal to -2. Sometimes they just want to make sure we're paying attention. So we will go over to where x is -2, starting at the origin. And then because x is negative, we're going to go left 2 units. It's right here. Go up and down, see if it touches our graph, and it sure does right here. So I want to look over and find the y. So f of -2 is equal to the output of 2. Again, we went to -2, found it where it touched our graph, and looked at the y-axis. So our answer here would be 2.